Hello, my name is Paulina Chin. I'm a senior developer at MapleSoft, and today we're going to talk about different ways of shading 3D surfaces. First, I'll start off by giving you an introduction to the most basic ways of shading in plots. Then we'll look at some more advanced techniques, and I'll also show some of the newer features we have in Maple that you might not have had a chance to try yet. Okay, let's start with the introduction. First, I'll talk about the color and shading options for 3D plots. If we call the plot 3D command to create a surface, then a default shading is used that's based on the X, Y, and Z coordinates. It's easy to change this default shading. Here, I'm using the shading option and giving it a value of Z grayscale. And as you see, we get a plot with that's shaded in grays. Now, if you want to see the different values that you can use for the shading option, go to the Plot 3D option help page, and if you scroll down to shading, you'll see a list of all the values that it can take. You can also use the context menu. So the different shadings are under color, and you can choose any of these values to change shading to the one you want. Now suppose you want to color your plot just a single color. Here you would use the color option. And here we go, we have a sky blue surface. Now all the colors are listed here in the plot color names help page. Actually, I shouldn't say all the colors, because as I'll talk about in a short time, we do have some different palettes with other colors. These colors all come from the HTML palette, but already here we have a long list. So I mentioned the idea of palettes. One palette we have is called the Niagara palette, and here I'll use a color from that palette by putting the palette name first in the string. Now you might wonder, well, how do I find out about these palettes? The ColorTools package has a number of useful commands. The get palette command shows you all the colors in palette. So here is the list of all the colors in Niagara. And the HTML colors that I talked about earlier, we can see that list also. I encourage you to go to the ColorTools help page. You'll find some very useful commands there to play around with colors, including getting a list of the palette names. There's also, as I showed you before, the get palette command to get all the colors in the palette. And not only that, but there are commands to add your very own palettes. Let's move on to the next section, which is coloring by X and Y values. So in the previous section, I showed you different ways of doing the surface coloring in terms of a single color, or using one of Maple's preset shading schemes, which includes coloring by XY values. The difference is that before, you have to use Maple's default XY coloring scheme without being able to customize the values. But now I will show you ways in which you can actually specify the actual colors based on the X and Y values. So let's first define this function that we want to plot. Here, notice that the function is defined as a procedure. We give the ranges, and we give as the value to the color option a procedure that returns a single value, which in this case is just the product of X and Y. When the color option has a single procedure returning a single value, then Maple interprets this as a hue color. The hue colors range from 0 to 1, but you don't have to worry about the scaling yourself, as this is done automatically. And as you see, you now get a plot that goes over the range of hues. In this next example, I am using just a simple sine function with ranges, and I'm giving a list of 3 expressions. Now, when the color option takes as a value a list of 3 different expressions or procedures, these are taken instead of hue values as RGB values, and the surface is colored using those RGB values, again scaled so that they're in the right range. This is what we call using color functions, and if you go to the Plot 3D Color Functions help page, you'll find a fuller explanation with some more examples of how this is done. You can also find out how, instead of using the RGB color space, you can use the HSV color space. Now, one thing I wanted to point out, or to remind you of if you're experienced with the Plot 3D command, is that it takes 2 different calling sequences. One is what we call operator or procedure form, where you give it a procedure and ranges, and the other is the expression form, where you give an expression and arguments of the type name equals range. When you use the color functions, you have to make sure that the value matches your calling sequence. So if you give a procedure as the first argument, then then color has to be defined as a procedure, and if you give expressions with names X and Y, or whichever names you choose, then you have to give the color in terms of those variables as well. Now I would like to talk about one of the newer plotting options in Maple, and this is called the color scheme option. In the color scheme option, you can give a list of colors, and this will cause your surface to be colored according to those colors based on the Z values. So your 3 colors, or however many colors that you provide, are distributed evenly over the entire Z range. And you could also use this marker sub option if you actually want to change the distribution of colors. Now, let me backtrack for a moment and talk about the different ways you can provide color scheme. The option requires that you give the name of the color scheme, which is Z gradient in this case. This is the one I'm showing you right now. The list of colors, and then any additional sub options that go with it. However, we allow a shortcut where you just give the list of colors, and if you do that, it assumes that you're using the Z gradient scheme and that you don't have any additional options. At the moment, we have in Maple 18, we have also a way of doing a custom coloring scheme that you can provide yourself, which I won't get into at this point because it's a little bit more complicated, but you can read all about it on the Plot Color Scheme help page. There's a section on custom color schemes. In future versions of Maple, we intend to increase the number of different color schemes that we provide. But at the moment, I'll show you what this looks like with the marker sub option. So what these numbers mean is that the shade red appears full red at 0.0. you get full yellow at 1, you get blue, sorry, not yellow, but I meant orange at marker 1, and blue at the 0.8 point, which because this range goes from 0 to 10 would be at 8. So that means that the place that's heaviest in blue is here instead of lower down here, where it would be at the 0.5 range between 0 and 1. So this is how you can adjust your distribution of colors. Now the color scheme option not only is available in Plot 3D, but it's also available for a number of other commands that create surfaces, and where you want perhaps to specify the color based on a set of values. So for instance, here is the density plot command. This also accepts the color scheme option and will color your surface according to the color list and color scheme. And again, you can use the full color scheme option with the sub options, or make your own custom color scheme. Now this video is mainly about coloring surfaces, but I just wanted to point out that the color scheme option is also available for some other plots which are not surfaces. Here I'm defining a set of points, and I'm using the point plot 3D command in the plots package. And here too, we allow the color scheme option so that you can color your points and have a gradual change from one color to the next. I also want to mention that if you give a single color, then you get the colors going from black through that color to white. And if you give no color at all, then you just get a grayscale shading. The final feature I want to talk to you about is another way of coloring a surface in a 3D plot. And this is by overlaying an image on top of a surface. So first I'm going to define the name of an image file that we've got saved in Maple already. And I'm going to plot this image on top of this surface, sine of y times cos of x, over these ranges. And I'll be doing this using this new image option. If you want to see this image as a 2D image in a 2D plot, you can do that using the plot surf data command, which also takes the image file. And here we go. So there are other ways of displaying images in Maple, but if you do it within one of these plot commands, you actually get the image as a plot element. This means that it's treated like any other surface in Maple. You can combine the plots using plots display, you can change the axes, add a title, you can do any of those things that you normally do with plots in Maple. So this brings me to the end of the video, but I'd like to point out a useful help page that you may want to look at. This is the Updates Maple 18 Custom Plot Shading page, and it covers a number of the topics that I talked about in this video. There are also some additional pieces of information you might find useful, as well as links to get more information. So I encourage you to try out the examples here. Thank you, and you can look forward also to more improvements in the area of plot shading in future versions of Maple.